Hello students, in this video we'll discuss about major data structures in compiler. So in the last video we have discussed about the translation process, like how an high level language statement will be converted into the assembly language statements that we have discussed. So now what are the data structure are going to be used while we are converting that high level language statements into machine level language statements or assembly language, how this buffered data will be stored, how we are going to remember all throughout those 6 phases, so which are going to help us to preserve these information, right? So here we are going to use 5 types of data structures. One is single global variable array, and second one dynamically allocated linked list, and third one most important symbol table, and fourth one literal table, and fifth one temporary files. So first we'll go with the single global variable or array. So in the first phase of the compiler, that is lexical analysis, so first we are going to generate the tokens. And these tokens, see, whenever an identifier is detected, like, or whatever the token is detected, that should be remembered for the next phase of the compiler. So where we are representing this. So generally, for all the tokens, whatever we are going to use in our subject, we are going to create an enumerated data type. You know about that enumerated data type, which is used in the C language, right? So to represent these tokens of a source language, we created the enumerated data types like identifier, operator, constants, whatever we are going to have. And based on that enumerated data type, we are going to represent we are going to recognize the tokens. So now sometimes we have to preserve some information about the tokens. Like for example, in the previous class, we have taken like this. A means identifier. So if A is identifier, then what is this A? Right? What type? What is the scope? Where it is being stored? Okay. So such information we shall preserve for the next phases. So in such cases, we are going to use arrays. So then arrays holds the lexema token, and it also store the information about it. Okay. So then if it is a single global variable, we can store one info or right. So a single info about the token. But if you want to store or if you want to preserve some other information, then you must go for the arrays, right? Then see guys, most of the languages, they are going to generate one token at a time. So in that case only they will go for the single global variable, because only one token. So once completion of detecting one token, then again we have to run the generation of token. So in that case also we use single locate symbol. But sometimes we have to remember more than one tokens, then this single global single symbol will not be useful. Or if you want to use more information about the token, then these variables will not be used. In that case, we'll go for the arrays. Then the second one is dynamically allocated linked list. See, in the first phase of the compiler, that is in lexical analysis, we generate the tokens. So how these tokens are remembered, that we have discussed, right? Then in next phase of the compiler, the tokens are going to be generated as trees, the parse tree. So what is the data structure we are going to use for the parse tree? Like for example, if you're having like this A, B, C. So if you assume that it is a binary tree, then this is the data, and this is the left child node, and this is the right child node. So for this, it is going to use the double linked list structure. So here we are going to use dynamically allocated linked list to generate the parse trees. So now we are going to have this node name, like for example A or B or operator, and this is the address of the left node, and this is the address of the right child node. So we use the double linked list to generate or store the parse trees. So we are going to use in both syntax analysis and semantic analysis. So for example, if a node is not having any left child, that is treated as null. You know about that, right? So this is simple double linked list node used to store the parse trace. Then we have a most powerful data structure in compiler, that is symbol table. Guys, listen here. Symbol table is a data structure which mainly maintains the information about identifiers. In some languages, the symbol table mainly maintains the information about identifiers. In some languages, the symbol table maintains the information about all the tokens. As we know that a table is nothing but collection of records. And what is meant by record? It is a collection of attributes. Right? It is nothing but collection of attributes. So attributes are nothing but the description of the token. For example, if you take here count. So count is a variable and it is detected as ID, identifier. So what is the name? Count. What is the type? Int. If it is a single variable like this, single symbol located, we cannot store the other information except the name of the identifier or token. And if you want to store the more information, you can go for arrays or you can go for the most powerful data structure called symbol table. And what is the size of it? What is the dimension? Where it is declared and where we are going to use and what is the address where we have stored, like that. We are going to use all these attributes to describe this token. Like that. See, semicolon. Int is keyword. That's why we have not inserted a record. Because in most of the languages, symbol table is mainly maintains the information about what? Identifiers only. So whenever an identifier is detected, it insert a record into the symbol table with the default attributes. And see, semicolon is special symbol, char is right. Now X is a variable, that's why we have created a record. And there is no record for char because it is a keyword. And there is no record for this because they are special symbols. Operator, string, special symbol. We don't have any record because the symbol table doesn't deal with that. Then immediately you may get a doubt. If symbol table is not storing other than identifiers, then who is maintaining info? Who is responsible for remembering all? Because the next phase we should update the type and scope or all information, right? Then who? Who has to take care about it? So where the symbol table is not maintaining the information about this, there the literal table comes into the picture. So all these non-identifier tokens, int, will be stored as string. Semicolon will be stored as character. Char will be stored as string literal. This stored as character literal. This will be stored as string literal. Like that, everything is going to be stored as a either character literal or string literal. And for everything, it is going to give a number based on the detection and address where we are using it. Okay. So when the literal table comes into the picture, where in which language the symbol table is mainly maintains the information about our identifier, there the literal table will be used to store the information about remaining all, right? So now in symbol table, as I told you, every phase is deals with the symbol table. So first in lexical analysis, whenever an identifier is detected, it just insert a record with the default information. Means it is not going to store the type, it is not going to store the size, it is not going to store the line of declaration. Then when the type and scope information will be updated, the lexical analysis simply insert the record with the default. Then the type and scope information will be updated by the right syntax analysis and semantic analysis. So this will be updated by lexical analysis. Like remaining all the information either will be updated by the lexical analysis or will be updated by the syntax or semantic analysis. But no other phase of the compiler, IR, optimization, they are not going to update any information into the symbol table, but they are going to retrieve the information from the symbol table. So then For example, where this literal table comes into the picture, means where you don't have the symbol table with all the properties, then the first lexical analysis, okay. So lexical analysis, what it will do, whenever an identifier is detected, it uploads the information into symbol table. And if others are detected, then automatically it will update in the literal table, where the literal table is connecting with the symbol table. So first it will search for the symbol table. If not, it will go for what? Literal table, like that. So each and every phase interacts with the symbol table, but the symbol table interacts with the literal table. So get the information and supply it back to the appropriate phase. So next, data structure. For example, you're not going to have enough space to store the complete program, which is going to be read each and every pass of the compiler. See guys, pace is different and pass is different. Pace means converting one form of code to another form of code, whereas pass is reading the whole code one time. So if it is a single pass compiler means, so or we can say that if it is a one pass compiler means reading the whole code one time. If it is a two pass compiler, right, so means reading the whole code two times, like that. If you want to read the whole code, we have to remember it, right? But the system sometimes may not have that much memory to remember, so that's the reason they are going to be stored in a temporary files. So once the task is done, then immediately the temporary files release that memory. So these are the data structures which are going to be used in compilation process. So in the next chapter, we are going to discuss about bootstrapping and porting.